G'day comrade subscribers. So thanks for your feedback, especially Leet Shotwave and Gary. So I made a few changes. So Leet Shockwave pointed out that even even when I've labelled the pins, people can still plug them in around the wrong way. So the way I had it, I had ground and 5 volts as pins 2 and 3. So if you imagine if you put it around the wrong way, you're going to short ground and 5 volts. So I've moved ground and 5 volts up to here. So that means if you plug it in the wrong way, so pin 4 you plug into pin 1, so the input goes to ground. So that's the input from the cassette recorder that you plug in, and then data out, which is output from the last inverter, but you can see it's pulled high anyway. And that goes into the ULA or BMC or whatever. That'll be pulled high, so shouldn't cause any damage. And Gary's comment about having the component identifiers on there, obviously it doesn't affect my circuit because my circuit will work perfectly first time, but I can understand. Of course I'm being sarcastic. So yeah, made a good point that if you want to troubleshoot, then it's much easier to identify, certainly compare with the schematic. So but usually with my stuff it's really quite simple, that you just put the parts on and that's all you need to know really. Definitely if you've got a more complex circuit, yeah, you definitely need the part numbers on there. But I was trying to make mine as small as possible. But we'll leave them on there because it's good practice, basically, isn't it? It's good practice to do it all the time. And that reminded me also that, because I don't understand why we need to use all 6 inverters. Obviously there's a reason, the circuit's there for a reason. So there is actually an alternate design that the Ukrainian guys gave me. So this is similar, this is using the same CMOS hex inverter. And but they only use 3 of the inverters. So you've got the input from the tape here, so similar. We're going through capacitor and resistor, and we've got an inverter, but then we've got a pair of diodes, and another capacitor, another resistor. So I guess kind of similar. Whoops, oh, I don't know what I did there. And then we've got 2 inverters. So yeah, but apparently this is also a mag in is the input to the BMC or the ULA. So apparently this is a well-proven circuit as well. So this might be something worth looking at as well. But for now, I'm just going to try this one out. I'll probably do both at the same time because they're quite small boards. Get them both fabbed and compare them. But yeah, so what I've done here is I've added an additional pin header sort of thing, just to make it a little bit easier. Obviously it's not really needed, because you can just put the analyzer or the oscilloscope on the output of each pin. But anyway, so I've added that in, and yeah, so I switched to the schematic. So I just thought, just redo the whole thing. So I've done some basic editing here. So I've moved the component values to the front silk screen so that they will be visible on the silk screen, and I've left in the component IDs. Yeah, and then I've added, this is that additional kind of testing output. So I've made it a vertical one, so it's really quite small. So you can either use it or not use it. So I'll go and basically make the PCB again, and then we'll see about getting it fabbed. Okay, here we go. That's our underneath text. So let's draw up our actual PCB. Like so, leaving a bit of space so we can have our little fillet corner. I think like that. I think that's probably okay. Right, now Let's fillet our corners. I think 1.5 is enough. There we go. And let's add, excuse me, let's add a ground plane. That one, I think. That one, yeah. No, it wasn't that one, was it? Draw filled zones. Ah, okay, no, let's, okay, there we go. And we want it ground plane. Da, da, da. Okay, so one interesting thing I noticed, because I've added in these kind of test points, so we've got inverter 1 output there, which is right there, pin 6, but it's connected to the resistor over here. Although, okay, now having said that, yeah, it's going through, so it probably means connection there. Okay, and I'm just a bit worried that it was going from here all the way over to here, and then here was going back over to there, but I'm not as clever as KiCad is. Okay, so I've got the ground plane set in, so if I do the auto routed, I think the ground, it shouldn't worry about the ground, I think. So let's save that. Free routing. Okay, start now, there we go, and yep, okay, so it hasn't done the ground because it knows there is a ground plane going to be coming, and let's go fill it, fill all zones, there we go, so you can see it's connected into the ground plane there, and on the chip down here. Excellent. So that's it done. Let's just move where I think, oh, I don't know where my text is going to go. I guess it's going to go there, but it's going to be, let's flip the view actually. Where was it? Over here, flipboard view. There we go. Let's turn off the front copper. Let's turn off the front silk screen. Turn off the back copper. Yeah, so we're going to be covering, text is going to be, oh, what did happen there? Ooh, be careful what I select. So maybe I could probably fit it, I could fit it somewhere by making the text a bit smaller and not writing so much rubbish. Yeah, anyway, so let's have a look. I'll sort that out later. Let's have a look at the 3D view. So there we go. We could probably move that up a little bit. Move the hole up a bit. What do you reckon? Is this okay? And obviously that there you don't actually need. You could just leave those holes in there. Yeah, I could maybe move this text over to this side here. Maybe. Alright, I'll do some more tweaking. Right, I think that's about done. I know one thing Gary also said is that he doesn't like covering, let's make this a bit easier, covering component values or identifiers with the actual component, so like what I've done here with the chip. But I figure, alright, you've put the chip in, the chip is what it says here. If you put the wrong chip in, I can't, there's nothing more I can do. So I hope that's one small concession. So let's have a look at the 3D view. So there we go. I know it looks a bit busy now, doesn't it, with everything on there, but that way you know you can just get the board and you don't you don't need a bomb because you've got everything on here. You can just, you know where to place everything. And then I've got a little bit of info there. Yeah, so I've tried, if we go back to the project manager with the plugin content manager, so the fabrication plugins, so there's two PCBWAY. There's PCBWAY plugin for KiCad, and then there's PCBWAY fabrication toolkit. So I checked with the PCBWAY guys, and this one uploads to the website, to their website, and this one generates the files on the computer, as you can see here, PCBWAY to your computer. So you've got two ways of doing it. So this one, so I might as well install this one as well. So you go install, apply pending changes, downloads it from PCBWAY GitHub. Okay, so let's switch back to, I guess it doesn't really matter. So here we go, tools, then we've got external plugins. So if we do this one here, and oh gee, that was quick. PCBWAY production, and then we've got the BOM, we've got the CS, we've got the Gerber files, netlist, and I guess that's the pick and place positionings for all the components. Too easy. All right, so you can just upload those. So one thing you could make this smaller by using surface mount capacitors and resistors. I prefer just to do through hole because it's simpler for everybody. You're not excluding anyone. They go, oh, surface mount, ugh. Whereas through hole is, everyone can do it, and it's not. It's a simple board anyway. So yeah, so you can go to PCBWAY now and upload those. But let's also try. This is probably going to ask me for logins and things. Okay. Ooh, okay, expecting value line 1. Ooh, we'll have to talk to them. That didn't work. Now that one is working. Okay, there we go. Cool. There we go. Yep. Oh, that's too easy. So it didn't work the first time, but it worked second time. So normally we can get 10 for the same price. $5. Yep, $5. And oh, okay, because it's uploaded everything else, you can actually get the assembly included as well. Cool. But I don't need that because I've got all the parts. If it was a lot of surface mount stuff, then especially with ICs and stuff, and as long as they're not obscure ICs, then yeah, they've got them in stock, then you can get them to do that for you as well. So I won't worry about that this time. $5 or extra urgent, $100. I think I'll just go $5, it's not that urgent. Okay, 10 pieces. So green is the fastest, 24 hours. We could go Blick. If you don't know why I pronounce Blick like that, that's from Lethal Weapon 2. Right, so that adds 3 to 4 days if I want to change the colours. So, let's go for green. Okay. That's pretty much it. That's what we expect there. Now shipping is $5, so that'll be global. Yep, global direct shipping. So that's the cheapest. You can see here. The problem is because I live rural. I don't live in Sydney. I live what I class in the country. So if I go for DHL, it says $21 here, but DHL, not PCBWAY, DHL adds I think $33 US. So it's about $55 US, which is, I don't know, 80 Australian, but it gets here very quick. But I'm usually not busy because I've got other things going on, so 2 weeks is pretty much for $5. I can live with that. And that's done. It's a way to go. So I can save that to the cart, Yep, agree. Okay. Too easy. Now I'll sort out paying for this. I've got credits still. I'll be back in about 2 weeks when the PCBs arrive.